Hello everyone, welcome to this tutorial session to explain the use of space gas modeling to model the rafter or the beam B2. This video will help you to model the beam in your shed. To analyze this beam under the dead load and live load, you will calculate manually during your calculation, and then use the software to generate the load combinations. Then the software will run to give you the bending moment diagram and shear force diagram and also the deflection. So I'm sharing now with you the rafter. So for example, if we have a rafter or a beam, this beam is 12-meter length, and we have found or have calculated the dead load of this beam as 2 kilonewton meter, 2 kilonewton per meter for dead load or G, and we have live load of 4 kilonewton per meter. Okay, so this is our beam, and we need to, or we will model this beam on the software so that we can understand how to use the software for modeling. Okay, so let's now start sharing the model, the SPACEGASS model. So this is how the software looks like, the interface of the software looks like. So the first thing we need to make sure about when we are using the software SPACEGASS is the units. So if we are open structures tab here, and then the first uh, icon here is units. So the units we will be using is meter for length, millimeter for the section properties, megapascal or Newton per square meter for material strength, mass density kilogram per cubic meter, forces in kilonewton, moment in kilonewton meter, mass kilogram, acceleration meter per second square, deflection or translation millimeter, stress MPa. Okay, so let's save now the units, and these units are the units we will be using during our analysis. So the first step is to make sure what is the unit you are using for the model. The second step is we need to start drawing our beam or our rafter. So if we go back to our rafter, so as you can see, our rafter is span is 12 meter. So to draw this rafter, we will need to specify the start point and the end point for our beam. So let's say this is our start point and this is our end point. Okay, so we have 2 points. We have point, let's say point A. Okay, so we have point A and point B. So this is our point A and we have point B. So to draw the member or the beam on the software, we need to know the coordinates for point A and point B. So if we assume that we have an axis, 2 axes, the first axis is y-axis, and we have horizontal axis, this is x-axis, so that we can build or determine our coordinates based on these 2 axes. So this is vertical axis, axis y, and we have x-axis here. Okay, so now this point A, is at the origin of the two axes, so we will assume that the coordinate for this point are 0 in x and 0 in y. So this is the coordinates for point A. So for point B, we are still on the x-axis, so y will be 0, and we have moved 12 meters, so the coordinates for point B are 12 in x and 0 in y. So now if we know the two coordinates or the 2 points coordinate, we can start drawing the rafter on the software SPACEGASS. So let's go back to our model. So now let's start. Here the software specifies the origin, which is 0, 0, and 0. So let's start how to draw a node or a joint in SPACEGASS under structures. So you have nodes. So you can draw nodes or using the data sheet. So if we start using data sheet, the data sheet will help us to draw more than one point at same time. So what we will do is click to add the first node. So the first node is node number 1. X is 0, Y is 0, and Z is 0. So the software asks us to add the Z coordinate as well. So as our beam is, we are drawing in 2D, so we don't need Z, or Z will be 0 for all the nodes. So this is our first node. So now we have node at the centroid or the origin 0 and 0 and 0. Okay, so we should have added the second node, the second joint before going out, but let's go back again to the data sheet. So click here to add the second point. So we have 12 in X, 0 in Y, and Z. So you can add as many point as you want and then click OK. So in this example, we have only two nodes. So those are our two nodes. So now we have drawn the first and second nodes. So the second step is to draw the member or the beam. So under member, draw members. Then what you will do, just to connect the origin point to the origin point to the other point here. So from the node, if you also want to hide or show the origin point, you can click this option here. So let's hide this one, and now we connected this node. So under members, draw members. So from this node to this node. So this now is our member. So our member is now 12 meter, which is the length of our beam. The next step is to specify the supports for our two nodes. So if we go back to our example or our beam, one of these supports are hinged support, the other one is roller support. So you have to assume one hinge and one roller. So now if we go back to our model, so to apply the supports, you need to click the point here. So you need to skip first. So after you finish drawing, you need to skip. Then under structure, node restraint. So node restraints will help you to assign the supports. So if we click node restraint, we will select the first node. So this list will show up here. So the first one is fixed support, second one is hinge support, third one is roller support. So we will select hinge for this support or for this node, then click OK. So nothing has changed, because if you want to show the support in this software, you need to click this option here, show node restraints, to the left here. So if we click this option, so now the hinged support or the pin support show up. The next step is to click the other support, and then if you look to the right here, we have also some lists. So you can click this list, it will show up same list of the restraints. So you can find it from the shortcut here or from under supports. Sorry, under structures, node restraint. So both are same. So just click the ruler support, click OK. So now, if you look to the beam, now this is our beam. We have 12-meter beam. One support is hinge to the left, one support is ruler to the right. So this is our first step. Draw the member, then assign the support. Our next step will be defining the material and cross section for the member. So what we will do now is click the member, steel member, and also go to properties. So in properties, we have two sections we need to fill. The section, this one here, section part and material part. So for the material part, the material you are using for the rafter is steel. So you need to click this book here. This book is the library of the software, and under steel, click steel, and then select and OK. So now, after you select this, the software will understand that the material of this member is steel. The second part, or the second step in this part, is select or define a section or a cross section for the member. So also from the book, the library of this software, you go to the steel sections available in the Australian market or other markets as well, like British and China and Euro and so on. So what we are using here is we are using universal beam for rafter, universal beam if you are doing a column, but here we are universal beam. So this is the list of the universal beam. So now you can select the rafter you have chosen for the member, because you need to assume the rafter in the beginning of the design. So you can select, for example, 360 UB44.7, then click OK. So now we have defined the section and defined the material for the member or for our beam, then we can click OK. So now, as you can see, the software has converted our line to our steel beam or our universal beam, as you can see, based on the assumption we have made. If you want to change the view of this beam, you can click this option here. You can show it as rendered like this, or outlined like this, so show only outline of the cross section. The third option is line or wireframe. So this is how we draw it. So either of them are okay. So now after we draw the beam and we have assigned the supports and we have then define the material and the cross section, the last step in our modeling is the loading. We need now to define the loading on the member. So if we refer back to our example or our problem, we will find that we have two loads in this case from our calculation. Dead load G equal to 2 kilonewton per meter, and life load Q 4 kilonewton per meter. So this is the two loads we have. So we need to go back to the software. Now, if we go back to the software, we need to define two load cases for our beam. So now we have finished what we need to do here in structures. Then we need to go to loads. So what are the loads we have for this case? we have member distributed force. So using the member distributed forces and then data sheet. So now you can click add. So this is how to add the force. But we need first to select the member. So left click on the member, select the member, then loads, member distributed forces, and then add the member distributed forces. So the software will ask you the load case list. So how many load cases we have? Two. So I will add here one. So what you will need to do only, give a number to the first load case, then click OK. So now the software understands that you want to add a load, uniform load on this beam under load case 1. So now this load in X direction or Y direction or Z direction. So now if you look here, this is our Y direction. So our load is vertical, so it is in Y direction. So start Y means the first point here. End Y or finish Y means the point here. As it is uniform, so the load is constant. So start Y is -2 and finish Y also -2. So this means the load is uniform. And if you look carefully here, the load we are entering to the software is kilonewton per meter, similar to what we have in the example. So this is our first load case, the dead load. We can add another load from here, but it is better to click OK now. And then after finalizing the first load, we can add the next load. So the first load in the category 1, click OK. So title for load case 1. What is the did load the title for load case 1? We can name it as did load or G. Okay, so you can add the name like that. If you want to add it as only G, it's okay, but we understand it is G. Or another option, you can give it G here and did load here. Whatever the name you want, but it is did load. So now, as you can see, this is the did load. It's already added to the beam. If we want to show the value for the did load or the loading, so we need to go labeling. Under labeling, under show diagram annotation, click show diagram annotation, both, and then OK. So this show us the value of the load, 2 kilonewton per meter, and negative means downward. So as you can see the arrow here, so the arrows here show that the load is downward. So this for the first load case. Second load case, same. So we click the member again under loads, member distributed forces, then load case number 2. So you need to add a different number for each load case. So we have only 2 load cases. So click OK. So here now, this case 2, member 1. What is the load? The load, if we go back to the slide. So the second case life load is 4 kilonewton per meter. So go back. So we have -4. So then select the member again. Loads, member distributed forces. Case number 2. Okay. Then under start Y, -4 kilonewton. So finish Y -4 and then click OK. So the title for this load case, Q or life load. So case number 2 is live load. Case number 1 is dead load or G. So now this is the live load, and if you look to this list here, so this list show you the load cases you have entered. One for load did load G, two for live load Q, and if you want to show all of them together, so the two cases together, 2 and 4 kilonewtons. Okay, so this was for what? This was for the load cases or the loading on the member. So now if we refer back to our slides for the rafter, now what is the next step? The next step is the load combination. So if you refer back to your the examples I shared with you, the beam example and the requirement of the beam. So we need to calculate the bending moment diagram and shear force diagram based on the load combination. How many load combination we have for this beam? We have only 3 load combination. Load combination 1 is 1.35 G. Number 2 is 1.2 G plus 1.5 Q. Number 3 is 1.2 G plus 1.5 psi. Psi is a symbol here. Okay, psi L time Q. So these are the 3 load combination we need to use or we need to do for the beam. These load combinations are strength load combination. So these 3 load combination are strength or ultimate load combination. Okay, so we have 3 ultimate load combinations for the rafter, which are 1.35 G, 1.2 G, 1.5 Q, 1.2 G plus 1.5 psi L Q. Okay, so these are the load combination we have. We have another 2 load combinations. Number 4. We have 1.2 G plus W U plus psi CQ. And number 5 is 0.9 G plus WU. But these 2 cases are not applicable in our example and in your report as well because we don't have wind load for the internal beam. So no wind loads. So if you don't have wind loads similar to this one and this one, so this means that no formulas for or no load combination 4 and 5. So now this is the 3 load combination we need to input to the software. So if we go back to the software, it is very simple step. So what we will do is try to generate the load combination using the software. How to do that? Under loads here. So if you go down, combination load cases, this one option. Another option is a shortcut here, combination load cases. So if you click this combination load cases, click. So under load combination here, you need to click, then give the combination a number, let's say 10. Then what is the title for the first one? 1.35 times G. So the software asks you what is the factor you need to multiply by G and Q. So we have 0.35 G, so under G we have 0.35 and nothing for Q. Then click, left click. Then if you want to add another one, so click here and give it number 11. So the second one is 1.2 G plus 1.5 Q. So here is 1.2 G and 1.5 Q for this one, and nothing for 10 and 11, and then left click. If you want to add the third one, so give it the number 12. The third one is 1.2 G plus 1.5 epsilon L Q. Okay, so 1.2 epsilon L. So you need to say how much is epsilon L times Q, and then put it to the software, input it to the software. So how much is epsilon and how much epsilon L? So we need to refer back to 1170.0. So if we go back to the slide here, so you need to find this value together to input to the software. Okay, so you need to go to the standard or the beam design example I shared with you to find how much is this one. So I will just show the example with you. So this example here, if we open this example, not this one, sorry. So this example is for a roof. So we need to look to the floor because psi is different for each of them. Okay, so now if we go to this example here, based on the use of your building, for example, if it is offices, so short term 0.7, epsilon L 0.4. So let's assume it is offices. So how much is epsilon L 0.4? So if we go back to our example, so here this value. psi will be replaced by zero point 0.4. So we need to convert this value to 0.4. So this means the total value here is equal to 0.6. So in the software, if we go to back to the software, so the factor 1.5 psi L should be zero point 0.6. So this 0.6 come from 1.5 times zero point 0.4. So now we have generated the three root combination we need for the ultimate limit state. Then we can click OK. So the software show us all the load cases and load combination we have defined to the software up to now. So we have all of them here. We have G, Q, this is the two loads we have, and 1.35G, 1.2G plus 1.5Q, 1.2G plus 1.5 psi LQ. So this was the ultimate limit state load combination. If we go back to the software, to our example, we have another load combination for what? For deflection or for serviceability. Only another load combination, which we call it serviceability. So the serviceability load combination is only one. So let's take a copy from here. So what is the load combination for serviceability? It is G plus psi S Q. So this is our load combination for serviceability. If you don't know where to find this one, you can find it in 1170.1. And another option is you go to the example I shared earlier. So let's have a look on it. So for the serviceability part here, as you can see here, sorry, this is psi L. So we have G plus psi L times Q. So how much psi L here again? 0.4. So we will replace this with 0.4. So in this case, the factor for Q will be zero point 0.4 for the serviceability load combination. Okay, so if we go back to this one, so the serviceability load combination is G plus 0.4 Q. So now after we finish or we know the load combination for serviceability, we will go to the software to define this load combination. So using the same option here, same tab, click to add a new one. So this will be number 13. The title for this one is G plus psi Q. So the factor for G is 1. For Q, it is zero point 0.4 based on our or based on the standard. So after we finalize all of them, click OK. So now this is our model. This is the beam and the supports and the load. So now our model is ready to solve. So now the final step is to run the analysis or run the model. So using this tab here, analysis, click analysis and linear static analysis. This is the option we will use for this model. Then click OK. So the software has finished the solution or the model analysis, and now we can show our results. So the result starting in this section here, so we have the first one is displacement or deflection, second one is moment, third one is shear, fourth one is axial force. So for the rafter we need only moment and shear and deflection. So let's start by the moments, and this is the load. If you want to show the load, click. If you want to hide the load, click. So we need to hide the loads now. So now for the moments. So if we show the moments, this is the moments we have for all the load cases. So as you can see here, the red one is the maximum one, come from case 11, which is the load combination 1.2 G plus 1.5 Q. So the maximum moment for this beam is 1.5, 151.2 kilonewton meter. If you want to show all the cases together, so all combination load cases like that. So we have four load combination. If you want to show case by case or load combination by load combination, you can select one by one like that. But the best option is to show all the combination together so that you understand the moment from each load combination, and the maximum will be from the second one, 1.2 G plus 1.5 Q, similar to the manual calculation. So in your report, you need to show the manual or hand calculation plus the moments as well. Sorry, plus the software moments as well. So this for what? For moment. If we click the moment, so it will hide the moment. Now for shear. So for shear, this is also the shear force diagram. Again, the maximum moment, the maximum shear will come from same load combination, which is 1.2 G plus 1.5 Q. So it is 50.4 kilonewton. This is our shear force diagram. The third one is what? The deflection. The deflection will only come from the load combination G plus psi Q. So don't use the deflection from strength load combination. So as you can see here, how much is the deflection? It is negative 40.17 millimeter. So this also the deflection, and this is a deflected shape if you want to show the render. So this is the original beam location, and this is the deflected shape location. So you can show it like that or like that. So to summarize our work, the first step in our model is to draw the nodes, first node and second node, then connect the member by drawing the member, then specify the supports, one to the right, one to the left, then define the materials and the cross section for the member. So select the member, properties, define the section, define the material. Then after that, select the member, define the loads, member distributed forces. Then after you define all the load cases, define the load combination. So we have four load combination. The first three for strength, the last one for serviceability, then close. Then the final step is to run the model, linear static analysis, and then run. What you need to do is you need to take screenshots for the loads. For example, this is the load G and this is the load Q. So you can take screenshots for this two load cases. Then after you show the loads, then you can show the bending moment diagram for all load combination like that. So you can take a screenshot for this as well. Then if you want to show the moment, so click the moment tab. So you can screenshot this diagram here. This diagram will show the moments. Another screenshot for the shear force diagram. And the third one is deflection, but the deflection, we show only the deflection for the serviceability load combination, G plus psi L Q. And then you can take a screenshot of that. Okay, so this is the 4 or 5 diagrams we need from the Space Gas software, and that's it for the software Space Gas. So if you have any query or any problem, just please contact me to and let me know, and I will try to help you. Thank you.